Welcome to A demola, and today's lesson we're going to be talking about atomic structure and isotopes. This essentially will form the building blocks of all the chemistry that you're going to learn over the next 2 years in your A-levels. So it's really important to get this down and learn really well. So let's get straight into it. Okay, so to begin with, we're going to talk about atomic structure. And really, with an atom, we want to define that as the smallest unit of an element that can participate in chemical reactions. Literally, any definition we say here, just learn it. Like, there's so many marks in chemistry that you get for just defining something, and a simple 1 marks here and there, but they add up over time. So definitely be happy with your definitions. Now, in your atom, we're going to have these subatomic particles, your proton, your neutron, and your electron. And we've got it here as being protons plus, they're positively charged, neutrons are neutral, so that's the equals, and the electrons are negative, so they have a negative charge. You see that I've also said nucleons, so I've kind of singled out the protons and the neutrons, and I call them nucleons. That just means that they always exist inside of the nucleus. So we're going to have the diagram here. You can see your yellow circles are your neutrons, and your green circles are your protons. And then outside, surrounding the nucleus, you've got your electron shells. So we've drawn 2 here. Also, street name, orbitals. Yeah, but those are where your electrons are going to exist, outside of the nucleus in those electron shells. Happy days. Props to you if you can figure out which element this is, by the way. So look at the periodic table, maybe have a think about that. Now, subatomic particles as well is quite important. So the subatomic particles, your protons, your neutrons, and electrons, we compare their charge and their mass in relation to each other, just because obviously these are really tiny. If you think that atom's tiny enough anyway, these are really tiny. So we're going to compare its charge and its mass to the other ones. Yeah. So a proton is a relative charge of +1 because it's positive. The neutron's neutral, 0, and the electron's -1 because it's negative. In terms of relative mass, what we can see here as well is that your proton and your neutron have roughly the same mass, whilst your electron is going to be a lot smaller than that. So normally we'll say 0.0005 or 1/2000. Sometimes they'll let you say 0, and they'll say that the mass of an electron is ineligible, but I would say probably stick to these ones if you need to. In terms of your subatomic particle structure of an atom, that's kind of all we're really concerned with right now. So we're going to move on to the next part now. Okay, I'm really going to try and drill this home over the course of these lessons. But in chemistry, your definitions are so essential because you can pick up such easy marks by just knowing the definition of things. So for this topic, our key terms are going to be mass number and atomic number. So your mass number is the number of protons and neutrons. In the nucleus, like we said, these are nucleons. They always stay in the nucleus. Whilst your atomic number is going to be the number of protons in the nucleus. And normally you're going to have it defined as this. So you can see X being your chemical symbol, whatever element you want, aluminium, chlorine, xenon, whatever. And you have Z as your atomic number and A as your mass number, which we've just defined. Just be aware, sometimes they might flip that over. So sometimes Z will be on the bottom, A will be on the top. Just be happy that Z is atomic number and A is mass number, yeah? I think normally they will probably tell you in an exam. This guy's going to be a key player throughout your whole chemistry course. This guy's going to be a key player, your periodic table. So be really happy with seeing like different groups, with understanding what things mean. So you can see here's your key with the atomic number on the top, symbol, the name, and then your relative atomic mass. Be really happy with looking at the periodic table and being able to say, what's the atomic number of, for example, magnesium? What's its symbol? What's its relative atomic mass? Be so happy with doing that because it's going to be really important throughout the whole of your A-level course. Okay, now we're gonna get into it a bit. So let's look at isotopes. Again, definitions. I cannot emphasize it enough. An isotope is atom of the same element with the same atomic number and different mass number. And if we use the knowledge that we've just had, we know that your atomic number is the same number of protons. Your mass number is going to be the fact that there's a different number of neutrons. So we're going to look at an example here of isotopes. We're going to look at carbon-12 and carbon-14. Now, the key player, the main one, is carbon-12. That's the most abundant one out of the isotopes of carbon, but other ones do exist. So as you can see here, if we zoom into our periodic table, carbon has an atomic number of 6 and it's got a mass number of 12. So, like we said, we're going to think about it like this. If your atomic number equals the number of protons, then carbon must have 6 protons. Happy? Cool. In terms of finding the number of electrons, if the atom is neutral, then it's going to be the same as the number of protons. So if this carbon atom is neutral, which it is, we're going to say that carbon, if it has 6 protons, it must then have 6 electrons. So now what's left is to find out the number of neutrons. So we know that the mass number is the number of protons plus neutrons. We already have the number of protons, right? 6. So if we do 12, which is the total mass, take away 6, which is the number of protons, all that's left is the number of neutrons. So we're going to have 6 neutrons in the carbon 12, as you can see in this table here. Now, I know you can see big red. Carbon 14 actually has 8 neutrons. And again, it's going to be about the same rationale. So instead, we now have the mass number being 14. And because the mass number is now 14, it just means that the number of neutrons has changed. So it's still carbon, 6 protons, still neutral, 6 electrons, but now it's going to be 14 take 6, which is going to get us 8 for the number of neutrons. Hope that made sense. Okay. Another thing that's really important to be able to do with this topic is to be able to calculate the number of each subatomic particle in ions. So again, mainly focusing on the electrons. But if we look at magnesium 2+, for example, let's look at the periodic table. So this is where our boy magnesium is. He's in the second group and he's in period 3. So we have, it's got an atomic number of 12. Its mass number is actually 24.3, but just for the sake of this example, we're going to stick to 24. We'll get into relative atomic mass in a later lesson, but we're going to stick with 24. Let's say that this magnesium is 1224 Mg2+. Now, if we take a pause for a second, let's go through a rationale and we're going to find out the number of each subatomic particle in this. Cool. Atomic number is 12, hence, that must mean that there are 12 protons. Happy days, we've got it off the list. Now, let's go to the number of neutrons. If the mass number is 24, I mean that mass number is neutrons plus protons, then if we do mass number take protons, all that's left is the number of neutrons, right? So 24 take 12, 12. Happy days. Cool. Now the number of electrons. This is a 2+ ion, which means that it must have lost 2 electrons because it's positively charged. So it lost 2 electrons. Hence, if the number of protons is 12, and we've lost 2 electrons, because if it was just a magnesium atom, it would be the same. So we've lost 2 electrons, then that must mean 12 take 2, 10, that's 10 electrons. And this will be your final table here. So you see our workings out as well. See our workings out. And that is what we get. So 12 protons, 12 neutrons, and 10 electrons. And you can have a look at the working out that we've done there as well. Okay, so in terms of the content for this lesson, that was virtually all that we had to do. So we've got a couple questions here. Pause the video, have a read, have a try, and then we'll come back with the explanations afterwards. So yeah, just pause the video and have a go at these questions, please. Okay, so I hope those questions weren't too challenging. Here are your answers. So if we're defining an isotope, like we said at the start, definitions are so important. We're going to say that it's atoms with the same number of protons but different number of neutrons. That's going to be completely fine for the exams. Now, then I think it was chlorine 37 that we had to work out. So you look at your periodic table. Chlorine, atomic number 17, must have 17 protons, right? It's neutral, so it must also have 17 electrons. Happy. Then, with the number of neutrons, we would have had to do the mass number minus the number of protons, which would have got us 20. 37 takes 17, 20. And that would be how we worked that out. Oh, cool. Then we had an aluminium ion for question 2. So again, we look at the periodic table. Aluminium is atomic number 13. Hence, there must be 13 protons. Its mass number was 27. So if we do mass number take number of protons, we'll get the number of neutrons. Again, same process. So 27 take 13, we get 14. Happy days. Now, it's a 3+ ion, right? 3+ ion, which means it must have lost 3 electrons. And because it's lost 3 electrons, we do 13 take 3, 10 electrons. Oh, that's all we need to worry about. Okay, 2b. So we had to explain why the aluminium was positively charged, I believe. Now, literally, in a question like this, you have to say lost 3 electrons. That's why I put it in bold. If you say lost 3 electrons, the examiner is laughing. Okay, the examiner is so happy if you say you lost 3 electrons. So literally, that's going to be the main thing about this question, being really specific about how much electrons is lost, or if it's a different, if it's a negative ion, how many was gained. Yeah. So just be happy to say that in the exam. You can pick up more marks that way. Cool. And then finally, we said, why do isotopes have similar chemical properties or the same chemical properties? And literally, it's all to do with electrons. All to do with electrons. So the isotopes should have the same number of electrons. So same number, same arrangement of electrons in terms of you have the same number, then the same electron shells, stuff like that. And then the arrangement of those electrons is what's really determining the chemical properties of an atom. So I hope those explanations have been clear. Again, any questions, just leave them in the comments and I'll do my best to address them. We're coming to a close for this lesson, but I just wanted to leave off with the A-star tips. So things that you can do, 100% do. Memorize the definitions. Really, really, really important. Really easy marks to pick up in your exam. Be confident with calculating the number of neutrons in an isotope and electrons in an ion. I feel like if you're on an exam and they just give you the atom, you're laughing. But if they give you like an isotope or electron, just try not to get overawed or confused by it. Just stick to the principle. If we're calculating the number of neutrons, mass number minus atomic number, or mass number take the number of protons. If you're finding the electrons in an ion, what a trick that I used to do is atomic number take the charge of the ion. So even if it's a negatively charged ion, if you take away the charge, it is going to be the number of electrons. So what I mean is like, say for example, you have a chloride ion, Cl minus 1, yeah. If you do the atomic number 17, take away minus 1, you end up adding 1, with your maths. So it's going to be like 17 minus 1, which is going to get you 18, yeah? So it will work either way. If it's a positive ion or a negative ion, it will still be fine if you do atomic number take charge of the ion. Next tip. Remember that isotopes have the same chemical properties. Really, really, really important. Because sometimes maybe it's been a while since you covered it and you just kind of forget in the exam. So be really, really happy that isotopes have the same chemical properties. And also remember that your positive ions lose electrons and your negative ions gain electrons. Cool. What are the definitely do nots for this topic? Do not confuse mass number with atomic number. Because this is something that you cover at the very start of year 12. When it comes to exams in year 13, it might be something that you might have been like, low-key, I can charge it, I don't need to cover. But make sure that you're really happy that mass number and atomic number are different and what the difference is. And also definitely don't forget the charge when dealing with ions. It can be really, really easy to go through the question and then forget, oh wait, it was a +2 ion. I needed to take away the 2 electrons, yeah? Just don't be that person, yeah? So I hope this has been really, really helpful for you guys. Please subscribe. Leave any questions in the comments. I'm going to do my best to answer them. And I will see you in the next one. Bye for now.